Good afternoon. My name is Christina Kalman-Schüler, and thank you, Ernest, for the introduction. And I will be presenting about a copper substitution survey commissioned by the International Copper Association. We are DMM Advisory Group. We are an international management consultancy focusing on the mining, metals, and the diamond sector. The usual disclaimer, I don't need to read out, and the antitrust guidelines of the International Copper Association, which provide a framework for our work. There are two main themes which defines substitution in 2020. One of them is, of course, the COVID-19 pandemic and an impact of this pandemic on the demand. I just read out some highlights, how we analyzed the different end-use sectors, because the different end-use sectors were impacted to a different degree. For example, the utilities sector, where energy generation and distribution, the long-term objectives, and often these industries have also a government mandate, and these were not really impacted by COVID-19. Some sectors, some utilities even restocked at the low copper price. On the demand for home, household, and consumer appliances was extremely strong during the pandemic. A very good example of that, people installed additional air conditioners in their houses because they work from home. And of course, this had a very good impact on the demand for equipment wires, winding wires for motors, industrial tubes, and electronic plate sheets, strips, and foils. On the negative side, we experienced a negative impact on commercial construction, not necessarily residential, but definitely a commercial construction. It was seriously impacted by COVID-19, leading to budget pressures, and we saw a negative impact on the demand for copper architectural, plate sheets, strips and foils, bare wires, and plumbing tubes. Similarly, the automotive sales have plummeted during 2020, and this had an impact on the automotive demand for automotive wires and some casting products. Of course, the second key theme of 2020 was that relatively low copper material cost in the first half of 2020. And just explaining you the chart on the screen, the green line is the copper aluminum price ratio. The blue line is the copper steel rebar price ratio, and the red line is the annual net substitution. And this analysis shows that there is historically a very strong positive correlation between the copper aluminum price ratio and the net substitution. And as you can see, the green line is increasing since 2017. But we experience a slight lagging of net substitution in 2020. So we expect the net substitution slightly catching up with the copper aluminum price ratio. Historically, a net substitution stands at 0.95% of the copper use. This is historically relatively low level, as you can see. And the chart I explained to you, the red columns is the substitution, the loss of copper use due to substitution. The blue part of the bars is the gain, where copper gains some market share against alternative materials. And the purple part of the columns is miniaturization, where devices becoming smaller and therefore use less material, but they don't use different material, they still use copper. The green line is the net substitution on the copper use, so it's a kind of relative measurement. And the yellow line is if you add up to the substitution and miniaturization, and this on the copper use. And you can see that the main line is, of course, the green line, which is slightly increasing since 2017, but still stands historically on a low level. Now, since last year, there was a slight increase on the net substitution, and the main reason was for this was that the large copper users were becoming more experienced with using alternative materials, and also the substitution gains. So initiatives which bring substitution gain, like energy efficiency regulations, undergrounding, or environmental regulation, were relatively slow in 2020. Also miniaturization, there was a lower incentive to bring new miniaturization solutions, and the existing miniaturization technologies reached their technical and cost reduction limits. But I think it's very important still maintain that many copper applications have limited exposure to substitution, as copper and copper alloys still provide the best cost performance combinations, and especially where high conductivity, electrical and heat conductivity, and corrosion and friction resistance is required. Now, what are the drivers in the change of net material substitution and miniaturization? On the left-hand side, you can see the slightly increased net substitution, and the main drivers here were the power cables, the copper alloys, plate sheets, strips, and foils, and especially the architectural applications, and to a certain extent, low voltage energy cables, which include automotive wiring and also to a certain degree building wiring.